Hello, and welcome to this session on building a basic Retrieval-Augmented Generation RAG pipeline. In this module, we'll walk through the fundamental steps to create a simple RAG pipeline, combining document retrieval with text generation. By the end of this session, you'll understand how to set up the pipeline, connect retrieval and generative models, and test the output. Let's get started. Why build a RAG pipeline? RAG pipelines are at the forefront of modern AI applications. By integrating retrieval mechanisms with generative models, they provide more accurate and grounded outputs. This interaction allows AI to fetch external information in real time, enhancing the quality and relevance of generated content. Use cases span industries, from healthcare to legal, providing solutions like dynamic chatbots, summarization tools, document search assistants. RAG pipelines ensure AI systems stay updated without frequent retraining, allowing greater scalability and adaptability. Step 1. Environment preparation. Before diving into the code, ensure your environment is set up correctly. This includes installing key libraries for building the RAG pipeline. Step 2. Document preparation. To build the retrieval component, we need documents to query. For this example, we'll create a small corpus manually. You can later scale this by importing larger datasets. Step 3. Vectorizing and indexing documents. Next, we use Face to vectorize and index the documents. Vectorization translates text into embeddings that allow similarity-based retrieval. Step 4. Querying the retriever. Once the documents are indexed, perform a similarity search to retrieve the most relevant document. Step 5. Generative model for synthesis. Once the relevant documents are retrieved, we generate responses using a Hugging Face generative model. Step 6. Full pipeline integration. Now, integrate retrieval and generation into a seamless RAG pipeline. Testing and refinement. Test the pipeline with various queries to ensure proper retrieval and generation. Refinements. Adjust K. Increase K to fetch multiple documents for broader context. Fine-tune embeddings. Use domain-specific embeddings, e.g. BioBERT for medical. Optimize generative model. Fine-tune BART or switch to T5 based on the task. Troubleshooting. Low relevance. Ensure embeddings accurately represent the dataset. Slow response. Use FICE GPU or batch queries to improve speed. Hallucination. Increase K and combine documents before generation to improve factual accuracy. Real-world application. Consider a customer service chatbot powered by RAG. It fetches FAQs and internal documentation in real time to provide accurate and timely responses. This setup dynamically updates without needing model retraining. Example use cases: legal assistants querying case law, medical AI pulling from research papers, e-commerce bots generating product recommendations. In this session, we walk through the essential steps to build a basic RAG pipeline, from indexing documents to generating responses. As you continue, consider expanding this pipeline by integrating larger datasets or fine-tuning the generative model for domain-specific tasks. Thank you for joining this session. In the next module,